This is a video from section 9.3 in a Calculus 2 class. An equation that involves one or more of the derivatives of a function is called the differential equation. For example, y double prime plus y equals 5 is a differential equation. Y triple prime plus 3y double prime plus 2y prime minus 5y equals sine of x. This is another differential equation. So notice how it involves the function y and one or more of its derivatives. The order of a differential equation is the highest order of the derivative that appears in it. For example, what is the order of y double prime plus y equals 5? So because of this y double prime here, the order of this differential equation is 2. If we look back at this second example here, notice how we have y triple prime plus 3y double prime plus 2y prime minus 5y equals sine of x. Because of this y triple prime, the order of this differential equation happens to be 3. A separable differential equation is an equation that can be written in the form dy dx is equal to f of x over g of y, or dy dx is equal to g of y over f of x, where f of x and g of y are differentiable functions. Such an equation can be solved by bringing the x's to one side and the y's to the other side. So if we look at dy dx equals f of x over g of y, this differential equation can be written as g of y dy is equal to f of x dx, right here. And the key to solving this differential equation is to integrate both sides. And so the integral of g of y dy is equal to the integral of f of x dx plus c, right here. Just like when we were back in chapter 7, when we integrate, we're going to have to add c to get that family of functions. If we're given dy dx equals g of y over f of x, this differential equation can be written as 1 over g of y dy is the same as 1 over f of x dx. And then integrating both sides again, we have the integral of 1 over g of y dy is the same as the integral of 1 over f of x dx plus that constant c. And with that, let's do an example. Suppose I ask you to solve the differential equation. And remember the object of the game, okay? It's to bring x's to one side and y's to the other side. And with that, we are going to take a look at problem number 1. Suppose I had dy dx is equal to 3x squared y squared. Okay. Now, we can write this as follows. We can say 1 over y squared dy. So basically, I divided both sides by y squared. So I get 1 over y squared dy is the same as 3x squared dx. Okay. And then from here, I want to integrate both sides. So the integral of 1 over y squared dy is the same as the integral of 3x squared dx. And so the object here is to solve for y whenever possible. Now, negative 1 over y is the same. That's the integral of the left-hand side. So negative 1 over y is the same as x cubed plus c. And if you don't mind, I'm going to put over 1. Okay? Now, I'm going to take the reciprocal of both sides. So when I do that, I get negative y over 1 is the same as 1 over x cubed plus c. And so therefore, y equals negative 1 divided by x cubed plus c. Now, we're not exactly done yet, all right? So the question is, what's the answer to question 1? Well, there's really two separate things here. Now, we can have y equals negative 1 over x cubed plus c. That is true. But y equals 0 also works, and that needs to be included as well. Because if I take dy dx, that is also 0. And so that is absolutely a solution to that differential equation as well. And that's how we do problem number 1. So if we go ahead and take a look at problem number 2. Suppose we are given dy dx is equal to x over y raised to the 4th. And so we can write this as follows. We can say y to the 4th dy is the same as x dx. So you can think of it as sort of like cross multiplying. Now I'm going to integrate both sides. So the integral of y to the 4th dy is the same as the integral of x dx. So 1/5 y to the 5th is equal to 1/2 x squared plus some constant c. Now I'm going to multiply through by 5. So y to the 5th is 5/2 x squared plus, if you want, 5c, right? Now, I'm going to let k equal 5c. And so, therefore, y to the 5th is equal to, we got 5/2 x squared plus k. I can still solve for y very comfortably. So y is the 5th root of 5/2 x squared plus k. Now, if you look back at the original problem, y equals 0 is not a solution to this differential equation, right? Because we don't want y to be 0. We can't divide by 0, so it doesn't work for problem 2. Let's take a look at problem 3. Suppose I'm given dy dx is equal to x times the square root of y. Now, y equals 0 does work for this one, by the way, right? So, but let's solve this assuming y is not 0 for the moment, right? So I'm going to write this as 1 over the square root of y dy is equal to x dx. Integrate both sides. So 1 over the square root of y dy is the same as the integral of x dx. So 2 square root of y, right? That's the integral of the left-hand side, is equal to 1/2 x squared plus some constant c. Okay? Now, I'm going to divide both sides by 2. So square root of y is equal to 1/4, right? That's half of a half. 1/4 x squared plus 1/2 c. And I'm going to let k equal 1/2 c. So square root of y is equal to 1/2 x squared plus some constant k. And that should be 1/4. So wanted to double check that. So let's put a 1/4 here. Now, can I square both sides? So in other words, I'm going to take square root of y and square it. That's the left side. And on the right side, I'm going to get 1/4 x squared plus k squared. And so y is 1/4 x squared plus k to the second, right? That's how we solve for y. So the answer to this problem is y equals 1/4 x squared plus k squared, and then y equals 0. Because if you take the derivative of 0 with respect to x, you get 0, and most certainly 0 equals 0. And let's try problem 4. So on problem 4, we have x dy dx is equal to y plus 3. This is a really, really outstanding question, okay? Now, the first step that I'm going to do is I'm going to move the dx over to the right-hand side. And so we have x dy on the left side, and then we have y plus 3 dx on the right side. That's still not enough, okay? So what I need to do is the following. So I need to essentially divide both sides by y plus 3 and then divide both sides by x at the same time. In other words, I'm going to get 1 over y plus 3 dy for the left side. And on the right side, I'm going to get 1 over x dx. And then from here, we get to integrate both sides. So the integral of 1 over y plus 3 dy is the same as the integral of 1 over x dx. And now, we get natural log of the absolute value of y plus 3 on the left side. On the right side, we get natural log of the absolute value of x plus c. Now, as an instructor, am I happy that you get to hear? Yes, I am. But to get full credit, you're going to have to be able to solve for y in terms of x. That's the hard part about this problem, in my opinion. Okay, but it's necessary. And so, what do I do to solve for y? Well, we go like this. We're going to take e to the natural log of the absolute value of y plus 3. That's the left side. On the right side, we get e to the natural log of the absolute value of x plus c. Right? So, e to the natural log of the absolute value of y plus 3 is the absolute value of y plus 3. That's the left side. On the right side, we're going to get e to the c times e to the natural log of the absolute value of x. Okay. Now, what does this all mean? Well, let's go a little bit further. We get the absolute value of y plus 3 is the same as e to the c times the absolute value of x. Okay. Now, what does that mean? That means y plus 3 is equal to plus or minus e to the c times the absolute value of x. Now, what I'm going to do is I'm going to let a equal plus or minus e to the c. And so that says y plus 3 is the same as a times the absolute value of x. And so solving for y, we get y equals negative 3 plus a times the absolute value of x. And that's how we solve problem number 4. Let's take a look at problem number 5. On problem number 5, we have x, y, dy, dx on the left side. On the right side, we have x squared plus 1. So I want to do one thing first, and that's divide both sides by x. And so we get y dy dx is equal to x squared over x plus 1 over x. Now, of course, I have to assume x is not 0. And so y dy dx is equal to x plus 1 over x. And so y dy, I have the y's on one side, and then I have x plus 1 over x dx on the right-hand side. Now I'm ready to integrate. So the integral of y dy is the same as the integral of x plus 1 over x dx. And so 1/2 y squared, that's the left side. On the right side, we get 1/2 x squared plus ln of the absolute value of x, right? So 1/2 x squared plus ln of the absolute value of x plus c. Multiply both sides by 2. So y squared equals 2 times 1/2 x squared plus 2 I didn't multiply it in yet. So we get 1/2 x squared plus ln of the absolute value of x plus c. So again, 2 is on the outside, 1/2 x squared plus ln of the absolute value of x plus c is on the inside. Now I get to distribute. So y squared is x squared plus 2 natural log of the absolute value of x plus 2c. Now, I get to solve for y. So y is plus or minus the square root of x squared plus 2 natural log of the absolute value of x plus, we'll call it k, where k equals 2c. And that's how we do problem number 5. Let's take a look at problem number 7. Suppose I give you the following. Suppose I get e to the y minus 1 dy dx on the left side, and on the right side we get 2 plus cosine x. And so what I want to do is I want to move that dx over to the right-hand side, and I want to rewrite this as e to the y minus 1 dy is the same as 2 plus cosine x dx. Integrate both sides. So the integral of e to the y minus 1 dy is the same as the integral of 2 plus cosine x dx. Well, we're basically done. So e to the y minus 1 equals 2x plus, e to the y minus y is equal to 2x plus sine of x plus c. And we're not going to solve for y in terms of x for this one. This is as far as we're going to be able to go. And that would be a sufficient answer for me. Yeah, so that's how we do problem 7. If we take a look at problem 8, and that'll be the last one for this video, suppose I'm given the following. Suppose I'm given dy dx is equal to 2x times y squared plus 1. Well, I could write this as follows. I can say 1 over y squared plus 1 dy is the same as 2x dx. And we're almost done. Integrate both sides. So 1 over y squared plus 1 dy is the same as the integral of 2x dx. So arctangent of y, that's the left side, is the same as x squared plus c. Okay? Well, but doesn't that say y is the same as tangent of x squared plus c? And that would be the answer to problem number 8. And that's a good stopping point for this video. This is a video from section 9.3, and we looked at problems 1 through 5, 7 and 8, and then I gave an introduction to separable differential equations. So, okay, thank you.